Welcome everybody. Thank you so much for attending my session, being here to the last session at VMworld 2017. If you were here last year, we had the exact same spot, so. Can't say that was the music that I normally would have picked for my walk-up music, but I'll go with that. So we're going to talk today about architecting SRM to meet your recovery goals. And my name is GS Kalsa. I work in technical marketing for the storage and availability business unit at VMware. And basically what that means is I'm focused on all things availability. Site Recovery Manager, vSphere Replication, stretch clusters, some cool stuff that we've got on the way as well. So today, I got to throw this disclaimer up there. I'm not really going to talk about anything related to future stuff, but if I do talk about anything related to anything that is potentially coming in the future, just know that I'm not going to specify any dates or time frames or if we're actually going to do it or anything like that. So that's basically what that says. So here's what we're going to talk about. We'll talk a little bit about protection groups and recovery plans, the different types of protection groups, different types of recovery plans, how to organize them, things like that. We'll talk about how you can architect SRM, how you can lay it out from a topology standpoint, the different ways that you could do that, some pluses and minuses to all of those. We'll talk about RTO and things that impact your RTO and within SRM and what you can do to improve your RTO or, you know, and as with most things in this presentation, there are trade-offs. So even if, you know, there are ways to reduce your RTO, but they're going to have impacts in other places, and we'll try and talk about those. I've got some recommendations, and then I've got a couple of demos that I'll try and run through at the end. So a lot of content. Let's get started. First off, just really quick, I already threw one of those pieces of terminology up on the board, and just to level set, make sure everybody's on the same page. Let's talk about RTO and RPO. So RPO, recovery point objective, you could think of it as this is how much data you're going to lose in the event of a disaster. So from the point that a disaster hits, this is how much data you just lost. And two examples that I use to hopefully clearly explain it is, let's say that you were doing backups, daily backups as your only DR plan. You know, that's the way that you retain your data is you just do daily backups. So your RPO is 24 hours because absolute worst case scenario, you lose your data center either just as you're starting to kick off your backup job or just, you know, before the last one finished or, you know, just somewhere in that space, you've just lost 24 hours worth of data. On the other end of that spectrum, say you're doing synchronous replication. So you're synchronizing your VMs, you're synchronizing your data across. If you have a disaster, your RPO is 0. You've lost no data. So two extremes, but just two different examples there. RTO, recovery time objective, is how long it's going to take you to get things back to the way that they were. So how long before everything works as it did before you had that disaster. Now, one thing that I want to point out about RPO and RTO is, in general, people might create them for their entire environment, but I would encourage you to break it down farther than that, to think of it either on an application level or even better, come up with just a few service tiers. You know, maybe you have 4 tiers of service from a DR standpoint. You know, you have nice small RPO, RTO for tier 1 and, you know, longer RPO and RTOs, you know, going out. It'll just make it a lot easier from the standpoint for you to manage because you won't have to think about what my RPO and RTO are for, you know, 100 different applications. You just lump everything into tiers. It also is going to make it easier for your business because when you talk to an application owner and you say, you know, if you just throw out the question, you know, what kind of RPO and RTO do you need? That's going to be a lot harder for them to answer than if you say, you know, where does your application fit into these service tiers that we offer? You know, that's going to be a lot easier for them to deal with. Okay, so protection groups and recovery plans. So first off, what is a protection group? And in this case, we are talking about protection groups from the context of Site Recovery Manager. So a protection group within Site Recovery Manager is just a group of VMs that you want recovered together. That basically is what all it is. So just think of it as, how would I want to group my VMs such that I want to recover those group of VMs together? Now, next question you might be asking is, well, how would I group them? How do I want to recover my VMs? And that is entirely up to you and your business. What makes sense for you? I would say that the thing that I see most frequently customers doing is organizing by application. So you take your email application, your web-facing application, your HR application, whatever those applications are, break those out and organize your protection groups that way. That's not to say that that's the only way to do it, though. We'll talk about some of the compromises and things and why you'd want to organize it one way versus another, but we'll talk about that in just a little bit. The one thing that I do want to point out is a VM can only belong to a single protection group. So each VM can only be in one protection group. So you can't organize it any other way to try and create flexibility. It's just one VM per protection group. Or not one VM per protection group, but a VM can belong to a single protection group. So how do protection groups then fit into recovery plans? And again, from an SRM context, what we're talking about with recovery plans is recovery plans are what you will run workflows on in Site Recovery Manager. And what I mean by that is the workflows in Site Recovery Manager are things like running an SRM test, running a planned migration, running a disaster recovery, running a reprotect. So those workflows are going to be executed at the recovery plan level. Now the thing is that protection groups can belong to one or more recovery plans. So you have some flexibility there. And this is what allows you to create kind of customized recovery plans where, in my example up here, we can recover our web application by itself and our email application by itself, and then we can also recover our entire site altogether. So let's talk about specific protection group types. So there's 3 different protection group types within SRM. The first one up here is vSphere replication. So vSphere replication protection groups are really simple to explain because you configure your VMs for vSphere replication, you replicate them, and you add whatever VMs you want to this protection group. Again, each VM can only belong to a single protection group, but it doesn't matter where those VMs are stored because vSphere replication gives you that flexibility in terms of where you can put your VMs, and you just add those VMs to your protection group. It gets a little bit more complicated when we talk about array-based replication. So if you think about how you're storing your VMs, with array-based replication, you're going to start out with a LUN or an NFS data store or something along those lines. You're going to create a VMFS data store on top of that, or you're going to present that NFS data store up to your hosts, and then you're going to put your VMs on that. Now, this is where the mapping to protection groups is. So in the top case, I've got a consistency group, so a replication consistency group. So on my array, I'm grouping those 3 LUNs together, and I'm replicating them together over to my recovery site. So those 3 are going to constitute a protection group. In the other case, you're talking about a single LUN constituting your protection group. The key thing to keep in mind here, though, is if you think about, let's say, take protection group 2, our email application. So on that LUN, those 5 VMs that make up our email application all have to be on that same LUN, LUN number 4, and no other VMs can be on that LUN as well. So the thing that you should get from that is that more than likely, if your environment is like most customers, prior to implementing SRM, if you want to organize it this way, you're going to need to rearrange your storage if you want your protection groups to align to applications. Because more than likely, the VMs that make up your email application aren't on the LUN by themselves with no other VMs on that LUN. So just something to think about from an array-based replication standpoint. The last type of protection group that I want to talk about is a storage policy-based protection group. And this was something that we introduced in SRM 6.1, and it's really nice if you have an environment that is dealing with a lot of automation, where you're creating VMs on a regular basis, and especially a frequent basis, and you want to enable your users to protect those easily. And I say your users protect those because I mean if you're using something along the lines of vRealize Automation or vRealize Orchestrator to spin up your VMs, and as part of those workflows, you want to give your users the ability to protect them, a storage policy-based protection group can make that happen. And the way that we do that is you create a protection group that's associated with a policy, a storage policy, and what you would do to protect a VM is, let's compare it to a regular array-based replication protection group, where in that case you would place the VM onto the replicated storage, and then you'd go into SRM, you'd configure that VM or add the VM to the protection group, and then configure it for protection. So you have multiple steps that need to take place within SRM. For a storage policy-based protection group, what we would do is you would associate the VM. I've got a nice little graphic of this. If you look up at the top here, you may or may not be familiar with it, but that second text box up at the top shows our VM storage policy. And so when you migrate or create a VM, you'll see that storage policy. And if you're not using storage policies, you probably have just never looked at it and just kept moving along. But if you're using something like vSAN, or if you've started experimenting with storage policies, you've seen that. And when you select a storage policy, it then changes the window below to show you what's compatible with it and what's incompatible. And so if you associate a VM with a storage policy that's associated with the storage policy-based protection group, and you place it onto that replicated storage, that VM will then be protected by SRM. You don't have to go into SRM to make any configuration changes or anything. VM's just automatically protected. And then the same thing from an unprotection standpoint. If you want to remove a VM from protection, again, just disassociate it from the policy, remove it from the data store, and the VM is now unprotected. Again, you don't have to go into SRM to do that. So that's our 3 different types of protection groups. So how should you organize? If you have questions, I'll do my best to leave time at the end. I'll definitely take questions towards the end as well. But how should you organize your protection groups? What's the way to make that work the best for you? And standard consulting answer is it depends. There is no right answer to how you should organize them. There are trade-offs, as with anything. So you can, we just think of it at a high level, more protection groups versus less. So what is that going to give us, and what are we going to lose? So with more protection groups, you're going to have a slightly higher RTO. I've got a demo that I'm going to show at the end, showing us failing over 10 VMs in a single protection group versus those same 10 VMs in 10 protection groups. And you can just see the difference in the time that it takes for that recovery. It also, having more protection groups also makes your environment more complicated, because if you think about it from a storage standpoint, you have to think a lot more about where does a VM get placed in my environment when I spin up either a new VM or a new application. It also is just more ongoing maintenance, ongoing operations. You got more protection groups that you have to think about. However, it also provides a lot of flexibility. If I want to test one particular application or fail over one particular application, I can do that. If you go down the road of more protection or less protection groups, it's less complicated. Your RTO is going to be a little bit faster, but you don't have that flexibility. When I want to test one particular application or fail over one particular application, I may or may not have that capability. So the right answer for you is going to be somewhere in the middle. Or, it could be on either end. It really just depends. Take a look at, what makes sense for you and what makes sense for your business. So let's talk some about topologies, the different topologies that SRM supports. So the first one, active passive, is the one that most people think of when they think of disaster recovery, where you think of, okay, I have my active site where all of my workloads run, and I have my DR site where I don't really do anything unless I have a disaster. And that works perfectly fine. That's obviously fully supported by SRM, and that's a good option. Again, it's simple. There's not a lot of complexity there. The second option is more of an active-active, where say you run your tier 1 and tier 2 workloads at one site and your tier 3 and tier 4 at the other one. And in the case of a failover, we're just going to power off or otherwise deal with the resources of those tier 3 and tier 4 workloads. You know, either just give them no resources or something along those lines when the tier 1 and tier 2 fail over there. That obviously is going to let you utilize the resources at both sides a bit better than with the first option, but obviously we're introducing more complexity. One of the other challenges with that second option, active-passive, is think about what's going to happen, say, a week after your disaster. Say if you have a disaster, your primary data center goes down, maybe, you know, fire or something that's more permanent. You know, how are you going to operate at that secondary data center long term? You know, short term, usually the business is okay with, you know, okay, yeah, we're glad you got our tier 1 and 2 tier 2 applications running. You know, but a week later, people are going to start going, okay, well, what about our tier 3 and tier 4 stuff? You know, when are you going to have that back up? And if you don't have the resources there to run those things, then, you know, that could be a problem. Now, not to say that you couldn't add more resources or something along those lines, but just, again, something to think about. So third option is bidirectional failover. You know, can we have production workloads running at both sites, and then each one of them is protecting the other? And yeah, that SRM fully supports that as well. So nice, flexible option. Again, it a little bit increased in terms of complexity. You know, your resource requirements are going to be a little bit higher. You're going to need, you know, ideally you really would only want to run at about 50% of available resources at both sites so that you had resources available to fail over, but again, just something to think about. And then multi-site. SRM supports a lot of different multi-site configurations, and we'll talk about those in just a second. So first multi-site configuration that we'll talk about is kind of a shared recovery, or this could even be a shared failure site. You know, let's say that you had, you know, shared recovery would be where we're utilizing the main data center to protect all of your remote sites. And going the other way could be, let's say that your primary data center was bigger than any recovery site that you had. You know, you have 2 or 3 recovery sites that can absorb the workloads from your primary data center, but no single one of them could absorb the entire thing. So a couple of different ways that you could potentially organize that. A few things to notice about this. You'll notice that we have a vCenter at each one of the sites. The SRM requires a vCenter at each one of those sites. SRM also is going to be deployed in pairs. So you'll notice that we have 3 pairs of SRM servers. The other thing to keep in mind is that each VM can only be protected once. So we couldn't say have a VM that was in our main data center protected to both remote office A and remote office B. So just a couple of things to think about there. Another option, this is specific to if you have remote sites that you're protecting back to a central site. Another option, and just to kind of highlight the flexibility of SRM, is you could, instead of deploying a vCenter and an SRM server at each one of the remote sites, deploy an SRM and a vCenter server actually at the same main data center. Because again, with this configuration, you're never really thinking about failing over from the main data center out to the remote sites. You're just thinking about protecting those remote sites. And so the idea here is that vCenter is going to be the one that's managing those remote sites, and then the SRM server will handle the failover. Now, obviously a downside to this is going to be that if your link goes down between your primary site and your remote sites, you're gonna lose vCenter functionality, which your VMs are gonna keep running just fine. But if you wanted to deploy additional VMs or change configurations or stuff like that, you could have some issues. The benefit is it's saving you buying 2 additional vCenter licenses. So, and having the complexity of managing those. So again, it's trade-offs. There is no right answer or wrong answer. It's what makes sense for you and what makes sense for your environment. Another option that you can do is kind of a triangle, square, a ring, whatever you want to think about it as. But you have each site connecting over to another one. You could even configure this in a star configuration. Really, SRM is really flexible. The limits are just that a VM can only be protected once, and that there's a maximum of 10 SRM pairs per one vCenter. So if, in our remote site configuration, you could have 10 remote sites failing over to one central site. That'd be the limit. Another option is SRM now works with stretch storage. So if you're not familiar with stretch storage, just really quick run through of that. Stretch storage is the idea where you have array-based replication, and you have two storage arrays, and those arrays are doing synchronous replication with each other, and then taking it a step beyond that synchronous replication, they're actually presenting the same storage to both sites as read-write at the same time. So this is solutions like EMC vPlex, NetApp Metro Cluster, IBM SVC does one, HP has a solution, Hitachi. I'm pretty sure all the major storage vendors have an option like this. Now, VMware can work with stretch storage. So VMware usually is deployed as a stretched cluster on top of a stretched storage. And the benefit that gives you is you can do things like you can vMotion VMs between those two sites. In the event of a disaster, the stretch cluster will recover with a solution like HA. If you're familiar with vSAN, vSAN supports a stretch cluster, same idea, fits into that same situation. vSAN, I'm not going to talk a lot about vSAN because this is an SRM session, but I will say we did some sessions about stretch clusters. If you're looking to do a stretch cluster, vSAN, you owe it to yourself to look at vSAN because vSAN is much less expensive and much easier to manage than any of the other stretch storage solutions. The downside with a regular stretch cluster is that it's a single vCenter. So we couldn't use SRM to protect between those two sites. And then you miss one of the benefits of SRM, which is the ability to non-disruptively test your recovery plan. So you don't have that ability. The only way to test a vSphere Metro storage cluster is to actually take one of those sites down and watch HA recover the VMs at the other site, which obviously would be disruptive. So all that preamble, as of SRM 6.1, we now support SRM with a stretch cluster, or with stretch storage. So you have stretch storage underneath, you have your typical SRM deployment, so a vCenter and an SRM server on top of that. And now what we have is the best of both worlds. So now you have the ability to vMotion VMs between sites, because you can use that cross vCenter vMotion that we introduced in SRM 6, or vSphere 6. And you have the ability to non-disruptively test your recovery plan. And on top of that, instead of having HA handle your recovery, which HA can do a good job of that especially as of vSphere 6.5, HA now has some functionality built into it around priority groups and dependencies. But it still isn't SRM. It's still not the level of orchestration that SRM provides. And then the bigger thing is you can non-disruptively test, and then you can also use SRM to orchestrate the migration between sites. So if you want to use SRM, if you want to vMotion a group of VMs from one site to another in the case of a disaster avoidance scenario, you can use SRM to orchestrate the migration of those VMs instead of you having to sit there and say, if you're going to migrate 500 VMs, do a vMotion of 500 VMs from one site to another, you don't want to have to sit there and vMotion groups of VMs one at a time, or even groups at a time for that full 500. SRM can handle that for you. So another topology that we can do is combining a stretched cluster. In this case, I'm showing a vSAN stretch cluster, but combining a stretch cluster with SRM. So if you remember before, I said that you can't use SRM to fail over a stretch cluster. And really specifically what I was talking about is you can't use SRM to fail over between the two sites that make up that stretch cluster. But if you have a third site, and if you're using a stretch cluster, more than likely you will have a third site because most stretch clusters require some kind of a tiebreaker component, which in the case of vSAN is that witness appliance. So more than likely you're going to have a third site anyway. So why not have that ability to deal with a failure in a metro area, where if you have some kind of an issue that takes out one of your sites in that metro area, the stretch cluster can help you with that. But if you have something that impacts an entire metro area, takes out both halves of your stretch cluster, you have something that can help with that as well. And I don't have it with me and I didn't have time to go through it anyway, but we have a demo that we'll put out on YouTube here shortly that one of my colleagues put together that actually shows a stretch cluster running We lose one half of that stretch cluster. The VMs fail over to the remaining half with HA. And then we lose the remaining half of that stretch cluster. We fail over to a third site with SRM. The stretch cluster comes back. We reprotect our VMs, and then we fail back to the stretch cluster. So all of that done in the demo is probably about, I don't know, 5 minutes or 3 minutes or something like that. So one last thing, just talking about topologies. If you're not familiar with enhanced linked mode, it was something that we introduced in vSphere 6.0. Enhanced link mode just makes it easier to manage your environment because you'll see your all of your vCenters in your environment that are part of an enhanced link mode. You'll see all of those vCenters in the same UI, and so enhanced link mode is, and it helps manage SRM. The whole way of setting up enhanced linked mode is you just have to join. When you deploy a new platform services controller, you join it to an existing platform services controller domain. So it's a lot like Active Directory if you're familiar with that, setting up Active Directory. Similar to that idea of sites within Active Directory where you set up an additional site, but joined to the same domain. Okay, so let's talk about how things that impact your RTO. So one of the big ones that a lot of people don't think about is decision time. If you think about RTO, how long is it going to take you to recover? And you time that from the minute that you hit the recovery button within SRM to when everything is back up and running, that's not an accurate picture of how long your RTO is. Because more often than not, there's going to be some period of time where your systems may be down and you're determining, do we want to fail over? Does it make sense to fail over? Are we going to fix the problem that's occurring at our primary data center? Does it make sense to fail over because, is there some other problem at our recovery data center? Who knows? But maybe it occurs on a weekend and, the junior admin isn't comfortable enough making the decision about the failover because, the application is performing, but it's performing poorly. Or, the floodwaters are rising and they're just not sure, they don't have the authorization. Whatever it is, think about decision time because it weighs into that overall number of RTO. Another thing to think about is IP customization. So one of the things that SRM supports is the ability to customize your IP addresses, to change IP addresses as part of failing over from one site to another. So when you do that in SRM, though, it's going to take a little bit of time. So if we look at what the steps are for SRM without IP customization, just specific to the VM, all that SRM is going to do is it's going to power on the VM and wait for VM tools heartbeats. So if you want to use IP customization, then we're going to add a couple more steps. We're going to power on the VM with the network disconnected. We're going to go through using VM tools and change the IP address. We're going to power the VM off, and then we're going to power it back on in the order that was defined earlier. So again, don't get me wrong, the thing that I'm not saying don't use IP customization. What I'm saying is that there's a time associated with it, and so just factor that into your plan. And if your concern is, what, I need to do everything possible to make my recovery time as short as humanly possible, okay, well then maybe you want to start looking at some kind of a stretched layer 2. Or maybe you want to look at moving a subnet from one site to another. If you're familiar with routing, the idea would be that you would work with your network team to just move the network from one site to another. And obviously the key there is you're going to need to move all of the VMs that are on that network, because once you move it to the other site, any VMs that are left over aren't going to be able to communicate anymore. But there are options. So you can look at a stretch layer 2, that'd be something like NSX, provides that capability. You could also look at, just moving the entire subnet. So a couple of things to think about. One thing I will say is if you're not looking at something like NSX that gives you the ability to stretch layer 2, but does it in a way that eliminates a lot of the issues with stretching layer 2, don't be surprised if you go to your network team and say, hey, I want to stretch layer 2 between sites, and they yell at you, because they don't like, if you think about failure domains, the more that you understand about things, it basically is making their life really hard and painful, stretching layer 2 between two sites, unless you're doing it with something like NSX. So let's talk about priority groups, priorities and dependencies. So within SRM, SRM has the ability, has 5 priority groups that you can organize your VMs in. And then within those priority groups, you can create dependencies as well. So let's just take a quick example of, let's say that we have 2 applications. And our 2 applications are just kind of basic 3-tier applications, database, app, web. And we need to make sure that they start up in that order, that the database server starts first, then the app tier, then the web tier. Okay, so we've got 2 different applications. I'm just going to show you 2 different ways that we could organize that and how that's going to impact RTO. So we have it set up to where we put one application in group 1. So the database server is going to start first, the app server is going to start second, web server is going to start third. That's going to take 10 minutes. And then we do the second application same way. That's going to take another 10 minutes. Our recovery plan just took 20 minutes to run, so not too bad. Here's another way that we could do it. If we put both of the database servers in priority group 1 without dependencies, we put both of the app servers in priority group 2, again without dependencies, and both of the web servers in priority group 3, again without dependencies, now our recovery plan took 10 minutes to run. So is there a right way and a wrong way to organize that? No. It's just 2 different ways. If RTO is really important to you, go with the second option. If it's really important that that one application, the entire application start before the second application, then obviously you're going to need to go the other way. The big thing is just make sure that you're thinking about those priority groups and dependencies holistically. That you're not, don't get in a vacuum and think, okay, I need to make this one dependent on the other one because that's the case. You can use priority groups or dependencies. You don't have to necessarily use one or the other. So thinking about things from an organizational standpoint for lower RTO. We talked a little bit about this before, but the idea of fewer larger NFS data stores or LUNs is going to improve your RTO. You'll have a lower RTO. Fewer protection groups, kind of the same idea there. Another one is not replicating your VM swap files. Now, this is something that obviously, as with most things, there's going to be a trade-off. So not replicating your VM swap files would mean storing your VM swap files in a different spot, not with the rest of the VM, which is easy, relatively easy to do. I believe it's a host level setting or it might be a cluster level setting. It's easy enough to do that. And the reason that you would want to, what's gonna benefit you by not replicating them is, one, you're gonna save in bandwidth and, CPU and processor and everything for your storage array that's replicating that across. But the other thing that you're going to benefit from is that when those VMs are recovered at the recovery site, you're actually going to save vCenter a little bit of work in trying to deal with that swap file. Because basically when vCenter starts a VM up, if it sees that swap file, it just actually has to delete it. So if you don't have it there anyway, you're just going to save vCenter just a little bit of time. Is it going to be a huge amount of time? Probably not. But if you're looking to improve your RTO in every way possible, that's something that you might want to think about. Fewer recovery plans, that's another one. So, we talked about how you can have a recovery plan for, potentially each different protection group. But if you're looking for speed, running one recovery plan with a bunch of protection groups is going to run faster. A couple other things from a VM configuration standpoint. So make sure that you have VM tools installed on all of your VMs, on any VM that you can install it on. And the reason for that is that by default, when SRM starts up a VM, the thing that it's going to wait for before it moves on to the next VM is it's going to wait for VM tools heartbeats to respond. And it does have a timeout. It's not going to wait forever. But having VM tools heartbeats, make sure that having VM tools heartbeats there just means that SRM is going to know that that VM started up correctly. And just so you know, you can turn that off. You can adjust the timer, and you can adjust that timer either on a global scale or you can adjust it on a per VM level. But I would just, as a general recommendation, if you have VM tools, if the VM can use VM tools, use VM tools. Another one is array-based replication versus vSphere replication. In general, I would say, and I don't have really specific stuff to point to yet, but in general, from what I've seen, vSphere replication will be slightly faster than array-based replication from a recovery standpoint with SRM. Now, I want to really emphasize, I am not saying use array-based, if you want to go faster with your recovery, chuck your array-based replication and use vSphere replication. Because there are obviously other factors in there between array-based replication and vSphere replication. I actually have a whole blog post out there, if you're curious, comparing the two. And there's, like 30 different things that you compare them on, and, there's lots of differences between the two. But just in general, because vSphere replication doesn't have to communicate with the array, it doesn't have to use the storage replication adapter, go out, talk to the array, wait for the array to respond, and go through that whole process. Just because of that, because vSphere replication is kind of natively built into vSphere and more tightly integrated with SRM and with vCenter, it doesn't have to wait as long. So your recovery is going to run slightly faster. Obviously, if one thing that array-based replication can do that vSphere replication can't do is synchronous replication. So, like if your RPO is such that it makes sense to use array-based replication, don't worry about it. That's what you need. Just something to think about, something to play around with in your environment if you want to. A couple of other things thinking about the recovery site. So, vCenter sizing. One of the things that you'll often see is that at a recovery site, people will think, well, normally my recovery site isn't really going to be doing much, so I'm going to make the vCenter there kind of small because, why waste those resources and whatever, leaving it there to have it not really do anything. The thing that's going to work the hardest in your environment during a recovery is vCenter. vCenter is going to be, doing all kinds of different things, from mounting hosts, getting hosts turned on, mounting disks to them, adding VMs into inventory, powering VMs on, connecting them to the networks, moving them to folders, all these different things that vCenter is having to deal with. So make sure to size vCenter appropriately. I would say at a minimum, you want it the same size that it is at your protected site. If you want your recovery to potentially, it could make it run even faster if you increase the size of your vCenter. So if you're looking for speed, one of the things that you could do is during a recovery plan test, keep an eye on vCenter performance. If it's maxing any of its performance out, then give it more of whatever thing is that it's maxing out. If it's maxing out its processor or its memory or something, give it more and see if your recovery plan will run faster because of that. One thing just to be clear, the SRM server actually doesn't work very hard. So, keep an eye on its performance and things like that, but don't worry about sizing of your SRM server. As long as you size it according to our recommendations, it's going to be fine. Same with the database. SRM database is really just a store for configuration. Most of SRM's work is SRM telling vCenter, hey, do this, do this, do this. And then vCenter is the one that's running around with its hair on fire. So number of hosts, that's another thing that can benefit, is if you want to reduce your RTO, the more hosts that you have for vCenter to power VMs onto, the faster your recovery is going to run. Just you're spreading that load around. Other thing that I see surprisingly often is people that don't have DRS enabled. And my kind of big question there is, why wouldn't you? And just from the standpoint of balancing, from a placement standpoint, not, if you don't want to turn it on in your environment because you're worried about, VMs moving around when you don't want them to, I could kind of understand that, not really, but what I don't understand is why you wouldn't want it there to just place your VMs on data stores so that it puts them, spreads that load out, spreads the load out on all of your hosts to get things balanced and up and running as quickly as possible. Another thing that you can do is if you've got multiple recovery plans and you have multiple clusters, have those recovery plans target different clusters. Because a lot of that work is going to be happening at the cluster level, and so if you can, again, spread that out, it's just going to make things run that much faster. So let's get into a few recommendations. So one of the big things, which is not technology related, but is still really important, is make sure that you're communicating clearly with your business. One of the things that it still surprises me that somewhere in the neighborhood I've heard of 50% of businesses don't have disaster recovery plans. But the thing that scares me even more is I wonder how many of those businesses have not communicated that with their business. Like how many business owners are not aware that they don't have a DR plan? And you as IT, it's important for you to have those clear and regular communications with your business about, what your recovery plan is, what kind of RPOs and RTOs you're offering. And I'm not saying you need to go out and spend money on it. If you don't have SRM, that you need to go out and spend money on an SRM in order to have a recovery plan. If your DR plan right now, if what you have is tape backups that somebody takes home with them every day, that can be a DR plan. You just need to communicate it to your business. Hey, look, here's our DR plan. We have an RPO of about 24 hours because we're backing up to tape. Our RTO, what our RTO looks like is, since all that we're going to potentially have in the end of a disaster is a box full of tapes, we're going to have to go out and buy new equipment. We're going to have to find a place to put it. And it's going to take us about 6 weeks to get back up and running. And that's our plan. And if the business owner goes, well, that's what I can afford right now, so that's what we're going to have to deal with, then great. Or if they go, oh my God, we're going to be out of business for 6 weeks, we can't do that. Okay, let's find something else. Great. Have that conversation. Just make sure that those communication is clear with clear with your business, that you're just on the same page and you're talking about the same things. Another thing that I want to talk about is frequency of testing. So a huge thing to me, I still think it's the best thing that SRM offers. The best feature of SRM is the ability to non-disruptively test your DR plan. So I would imagine most of the people here in this room have been through a DR test when you're not using a tool like SRM. And it's usually this kind of nightmarish thing of a weekend gone wrong where you're consuming massive amounts of Mountain Dew and pizza trying to get this folder full of paper that says things should work a certain way, but they're not actually working that way. And, the plan's changed and you've deployed new systems and just, and by the end of it, you're just so sick of the whole thing that you're just happy that you got production back up and running the way that it needed to be in time for Monday, that you just take that folder and throw it on a shelf and wait until the next year when you get to do that again. So SRM provides a solution to that. More frequent testing. It gives you that ability to non-disruptively test your recovery plan as often as you want. One of the things people ask me about somewhat frequently, which still kind of surprises me, is they ask me, how can I automate the execution of my recovery plan? How can I make it so that SRM will automatically recover my systems for me? And the thing that I always say is, I don't think you really want to do that. And they're like, well, why? Why would I not want to do that? It's like, well, how are you going to tell when your site is down? It's like, well, usually they don't say this, but they'll say something along the lines of, well, I'll just, I'll ping it or whatever. I'll check a website and make sure that the website's up. And it's like, so, if you want potentially a network problem, some little tiny thing that a system stops pinging or a website goes down temporarily for some completely unrelated reason to trigger a disruptive disaster recovery from one site to another. That sounds like a resume generating event to me. So the thing that you do want to do though, and you can do with SRM, is you can automate the testing of your recovery plan. So you can have a script that would run every week, every day if you wanted it to, depending on the size of your environment and what you're testing, and have it run that test and send you back, hey, the test ran successfully. The test didn't run successfully, and you can go in and take a look, see what went wrong, and fix it and run it again. But run those, use that non-disruptive capability. Run those recovery plans as often as you want, because you'll just be happier that you did. So test networks. When you think about how you're doing this non-disruptive testing of your recovery plan, there's two different ways that you can organize your test networks. And one of them is you can have SRM create a test network for you. So the way that that's going to work is that SRM will talk with each one of your hosts, and it'll create a port group on each one of your hosts, and that port group just won't have any uplinks. So it won't connect out and connect out to anywhere else in your environment. Now the advantage of that is you don't have to talk with your networking team to get that set up and configured. You don't have to work with anybody, you don't have to make any VLAN changes, change any trunking, anything like that. The disadvantage though is that your VMs that are recovered on a host are only going to be able to communicate with other VMs on that same host. And if they're on the same subnet. If they're on different subnets, they're not going to be able to communicate. So pluses and minuses there. The reason to use that is if for some reason you can't do the option that I'm going to talk about next, and you just want to test and verify that the SRM functions work, that it powers on your VMs in the order that you want. You might not be able to test your application, but you can verify that the SRM functionality works as you would expect. The other option that I would recommend, that you can do, and that I would really recommend if you have the ability, is to work with your networking team to create a test network. So if in your production environment you have 5 different VLANs and there's routing and firewall rules between those 5 VLANs, work with the networking group to create another 5 VLANs that have the same routing and the same firewall rules between them, so that when you run a test, you can connect your VMs to that test network and verify that things work as you expect. And obviously that test network would not be connected to anything else. It's isolated. And the thing that I'd recommend is you're probably going to get some resistance from your networking team unless they're really cool. And there are cool networking people out there, don't get me wrong. But they'll probably push back because it's going to be more work for them. It's something else that they're going to have to do. It's something else that they're going to have to maintain, and it's reasonable. But the thing that you can tell them is if they work with you to create this, you're going to be able to test your applications and know that they're going to work. And in the event of a disaster, the network team isn't going to get called. You're going to have a disaster, you're going to fail over, and things are going to work as you tested them. And it's not going to be this thing where the server team gets everything all stood up and then goes, hey, network team, fix it, because it's not working. And then everybody starts fighting and, usual shenanigans. So, test network, make sure to do that. Another really cool option, and I feel really lucky that I've got one of my friends and colleagues here, John Whitman, if you can come on up, John. John Whitman is a specialist in NSX, and specifically NSX in regards to disaster recovery. And he's going to show and share with you a couple of really cool things that you can do in this same space when you tie NSX in.
Exactly. Thank you, GS.
Yeah.
All right. Good afternoon. So being able to test your network holistically is a very key part in reducing RTO. And RTO is dollars. RTO equals dollars. So being able to test your network and actually know that it's functional and know that your recovery plan is functional is a very key part of the recovery plan. So with NSX, being able to virtualize that network, you're actually able to take and test your network on the same hardware with the same IP addresses, with the same routing, the same firewall rules on the same hardware right next to your production environment without any disruption. Now, does that make sense? That's an awesome way to test because you're actually able to stand up a duplicate production environment, run through the test, you get your east-west routing, you get your connectivity, you get all your firewall rules, but then you're able to test it. You can deploy a NAT gateway, you can deploy a jump box that allows you to get into that environment and actually test it, play with it, get an application owner in there to make sure that the full stack is up. Now what's nice about this is you can push that test button once a month, twice a month, once a week, every day if you wanted to. You can automate this testing to where it comes up, runs a test script, gives you a green light, gives you a red light, allows you to really go in there and just fine-tune your recovery. You want to play with the interdependencies of how machines are coming up. This allows you to do that, to actually stand it up in a secondary environment on the same hardware with the same IP address scheme.
So John, is there, there's that challenge when you have, when you want to stand up a test network of, working with your networking team to go through the process of creating that test network.
Exactly.
Are there things with NSX that can make that process easier?
Because we're abstracting the network layer, you don't have to work with your networking team. You can simply create this logical networking environment. You don't have to air gap. You don't have to go and put in a support ticket to create these secondary VLANs, to create this secondary routing environment. You, as the DR test personnel or the DR test administrator, can actually go in and create this NSX logical environment and stand up your test environment without having to interact with the networking team at all.
And there's some cool things that you can do with NSX, since everything within NSX is basically, at one level, is done through APIs and done through code. There's some things that you can do even to dynamically create a test network, right?
Mm-hmm. Exactly. So as you're going through and you're running your SRM recovery plan, if your networks don't exist in the background, SRM can actually call out to the NSX manager. You can run a pre-script that'll go in and actually create the networks for you and then clean it up after you're done. So you don't necessarily have to have all of this built and waiting in the background. As you run your SRM recovery plan, those networks will actually be brought up. Now this gives you some dynamic diversity as well, because if you want to just test a small piece of the environment, let's say you're recovering 1,500 virtual machines, and you only want to test a subset of them without disrupting the environment, but you don't want to have to constantly have this kind of air-gapped test environment waiting in the background, consuming resources. SRM can go out, talk to the NSX manager, create this networking in the background, create the uplinks for you. That way when you do bring up this environment or a piece of this environment, you're able to test it and then clean it up and have good data center hygiene.
Awesome. Thanks, John.
Thank you.
Yeah. And why don't you just hang out up here, because I know we'll probably have some questions.
Yes, sir.
So let's,
good demo.
we should have some time to go through at least one of my demos. Whoa, slow down. Okay. So in this demo, this is the one that I was talking about before, where we're going to run through, and I apologize, it is kind of fast, but I'll try and slow it down where applicable. So what we're going to do is we're taking a look here, and you can see that we have 10 VMs that flashed up there really fast. There's 10 VMs in there, I promise. So 10 VMs, and right now those are in 10 protection groups, and that was actually the protection groups first, and now these are the VMs. Oh, that was not what I wanted to do. Just a second. Okay. And there's our other 10 VMs in a single protection group. So now we're going to run through and kick off these two recovery plans. I think we're going to kick them off one at a time. Obviously, just kind of blazing through, watching the recovery plans run. In this case, we're running them in DR mode because you can see we had those errors and the plan kept running. The other thing that we did is in the recovery plan that's got 10 VMs, or 10 protection groups, we also did IP customization, and don't worry, I'll show you that time again in just a second. So finishing up the second recovery plan, just kind of blazing through there. Okay, so there you go. That's the results. So 10 VMs, 10 protection groups. IP customization took about 20 minutes. 10 VMs with one protection group. No IP customization took about 6 minutes. So obviously, your environment is going to vary. This is just to give you an idea of what that looks like. But just how those different things in there can impact how fast a recovery plan runs. So this next one that I want to show you, whoa, that was not what I wanted to do. Next one that I want to show you is kind of an example of some of the cool things that you can do with SRM. So this is in my lab environment. I've got 1,000 VMs. This is all running on a four node vSAN cluster. I've got those separated out by different application types. And I've got a recovery plan. I've got 11 recovery plans, one recovery plan for each application, and then a recovery plan for the entire site. So you can see that recovery plan contains all 1,000 VMs, 10 protection groups. So we're going to go ahead and run that recovery plan. 1,000 VMs. So I have it organized so I've got 200 VMs in each one of the priority groups. And just going to crank through here. Obviously, we sped this up a bit because I don't want you to have to sit here and watch paint dry, which is somewhat the equivalent of a recovery plan running. But we're going to power on those first 200 VMs, blaze through there, and the next, and then the next. And at the end of all that, I'm just going to speed through it. So we see all those VMs are recovered now running at Site B. We'll take a look at what that recovery plan looks like. And it took 25 minutes and 40 seconds to recover 1,000 VMs. So the point that I want to make here is not, these VMs were relatively small VMs. They're not running like heavy duty applications and they weren't sized really big. But the point that I want to make is not that, hey, look, SRM can recover all your VMs in 25 minutes. The point I want to make is that SRM is capable of running really fast. And it's not going to be the bottleneck in your recovery. It's going to be the time that it takes for your VMs to power up. Your dependencies, your priority groups, things like that. That's going to be what contributes a lot more. And this also hopefully shows some of the power of vSphere replication in terms of how fast and capable vSphere replication is for recovery. So that concludes my presentation. This is a quick recap. Oh, thank you.